Hi, welcome to ATR Speaks. I'm Abitha. Today, I want to talk to you about string related basic Java interview questions and answers. So, let's get started. The first question is explain string pool in Java. In Java, a string pool, also known as a string constant pool, it is a pool of pre-allocated memory space for string literals. The Java string pool is a memory area in the Java virtual machine where string literals are stored. When a string literal is created in Java, it is added to the string pool. The next time the same string literal is used in the program, Java can simply refer to the pre-existing string object in the pool rather than creating a new object in memory. And if the string object is available, then the reference to the string object from the string pool is returned. Otherwise, the new string object is added to the string pool and the respective reference will be returned. This can help reduce memory usage and improve performance. For example, consider the following code snippet. In this code, two string variables a and b are created with the same string literal hello. Since Java maintains a string pool, it will create only one string object in memory for hello, and both a and b will refer to the same object in the pool. This means that a double equal to b will evaluate to true. However, if you create a string object using the new keyword, Java will create a new object in memory every time, regardless of whether the string is already present in the pool. For example, in this case, even though the string literals used to create C and D are the same, Java will create two separate string objects in memory for each. This means that C double equal to D will evaluate to false. It's worth noting that the string pool is a specific feature of the Java virtual machine implementation, and not all JVMs may have the same behavior with regard to string pooling. And the next question is, what is an intern method in the string class? In Java, the intern method is a method defined in the string class that returns a canonical representation of the string. When called on a string, it first checks whether the string is already present in the string pool. If it is, it returns a reference to the existing string in the pool. If the string is not already in the pool, it adds it to the pool and returns a reference to the new string in the pool. For example, consider the following code snippet. In this code, a and b are two separate string objects, even though they contain the same string value hello. When intern is called on b, it returns a reference to the string in the pool, which is same as a. Therefore, the second print statement output true. Using the intern method can be useful in situations where you have a large number of strings that are likely to be repeated, such as when passing large text files or working with datasets that contain many string values. By using intern, you can reduce memory usage by ensuring that only one copy of each unique string value is present in memory. However, it is important to use intern judiciously, as adding too many strings to the pool can also have a negative impact on performance. Next question is, what is an immutable object in Java? In Java, an immutable object is an object whose state cannot be changed after it is created. Once an immutable object is created, its internal state remains fixed for the lifetime of the object, and any attempt to modify it will result in a new object being created with the updated state. So, to create an immutable object in Java, the following guidelines are typically followed. So, the first point is declare the class as final. By declaring the class as final, it cannot be subclassed and its behavior cannot be modified. And the second point is declare fields as final. All fields within the class should be marked as final, ensuring that their values cannot be changed once set. Third point is make fields private. Private access modifiers should be used for the fields to restrict direct access from outside the class. Fourth point is do not provide setter methods. Avoid providing any methods that allow changing the values of the fields. Instead, initialize the fields through the constructor or factory methods. And the final point is avoid returning mutable objects. If the mutable object contains references to mutable objects, ensure that these references are not directly exposed or returned from any methods. If necessary, defensive copying can be used to prevent modifications to the internal state. By following these guidelines, you can create immutable objects in Java that are thread safe, predictable, and can be safely shared among multiple threads without the need for explicit synchronization. Immutable objects provide several benefits, including simplicity, thread safety, caching and optimization, and predictability. Simplicity means immutable objects are straightforward and easier to reason about since their state cannot change. Immutable objects are inherently thread safe because they cannot be modified concurrently by multiple threads. This eliminates the need for synchronization mechanisms such as locks or semaphores. Caching and optimization means immutable objects can be safely cached or reused since their values are guaranteed to remain constant. This can improve performance and reduce memory consumption. Since immutable objects cannot change, they produce consistent and predictable results. Next question is, what is the main difference between a string and a string buffer class? In Java, the main difference between a string and a string buffer class is that string objects are immutable, whereas string buffer objects are mutable. When a string object is created, its value cannot be changed. Any operation that appears to modify the string actually creates a new string object with the modified value. For example, consider the following code. In this code, S1 is the string hello and S2 is a new string object that results from concatenating S1 with the string world. Here, the original string object hello remains unchanged. On the other hand, a string buffer object is mutable, which means that its value can be modified after it is created. This can be done using a variety of methods provided by the StringBuffer class, like append, insert, delete, and replace, etc. For example, StringBuffer sb equal to new StringBuffer hello sb.append world. Another important difference between string and string buffer is performance. String objects are immutable. Any operation that appears to modify the string actually creates a new string object with the modified value. This can be expensive in terms of memory usage and performance, especially when working with larger strings. On the other hand, string buffer objects are designed for efficient modification of strings. So, they are generally more efficient than string objects for concatenation and other string manipulation operations. String class uses a string constant pool to store the values, but string buffer prefers heap memory to store the objects. String overrides both equal and hashcode techniques of object class, but StringBuffer cannot override equal and hashcode methods. And the final question is, state the difference between StringBuffer and StringBuilder in Java. In Java, StringBuffer and StringBuilder are two classes that are used to represent mutable sequence of characters. The main difference between the two classes is that StringBuffer is thread safe, whereas StringBuilder is not. The StringBuffer class provides this thread safety by synchronizing access to the internal state of the sequence. On the other hand, the StringBuilder class does not provide thread safety. This means that if multiple threads attempt to access or modify a StringBuilder object simultaneously, it can result in race conditions and other synchronization issues. While StringBuffer provides thread safety, it can come at a cost in terms of performance because access to the internal state of a StringBuffer object is synchronized. It can be slower than using StringBuilder in situations where thread safety is not a concern. Therefore, it's generally recommended to use StringBuilder in single-threaded scenarios where thread safety is not a concern, as it provides better performance. And use StringBuffer when multiple threads need to access or modify a mutable sequence of characters simultaneously to ensure thread safety. Here is an example of using StringBuilder to concatenate strings. And here is an example of using StringBuffer to do the same thing. I hope you liked this video. If you did, please subscribe to my YouTube channel. See you soon. Bye bye.